Hello everyone, my name is Ghana Marwan from Class 8I in Al Hussan International School, Riyadh. Today I'm going to be explaining and discussing the topic radiation through a presentation that I have prepared. First of all, I'm going to be introducing radiation. What is it? Radiation is the emission or the transmission or the production of energy in the form of waves or particles. We have two forms of radiation, waves or particles, through space or a material medium. It is the process of sending off energy in the form of heat, X-rays, or nuclear particles. The heat transferred through radiation, or the thermal energy transferred through radiation, is moved through electromagnetic waves. Also, radiation requires no substance to travel from one place to another. It can move through a vacuum of space. Now, moving on, we're going to be discussing the types of radiation. There are three primary types of radiation. We have the alpha, the beta, and the gamma. So, we're going to be going into depth about each type of radiation. First of all, the alpha radiation. The alpha radiation, they are fast-moving helium atoms, which have a very high energy, typically in the MeV range. So here we have the electric units. We have the electron volt, the kilo electron volt, and the mega electron volt. So the alpha radiation has the MeV range, which is very, very large. Due to their large mass, as you can see here, this is the helium atom, which is in the alpha radiation. They are stopped just a few inches by air or a piece of paper. Alpha radiation does not typically cause radiation sickness, but instead it leads to lung cancer. This is basically the dangers of the alpha radiation. The examples of the alpha emitters include radium, radon, uranium, or thorium. We have the beta radiation. With the beta radiation, they are fast-moving electrons, which typically have energies of a few hundred kilo electron volts to several mega electron volts. Since electrons are lighter than helium atoms, they are able to penetrate further through several feet of air or several millimeters of plastic or less of thin metals. So basically, the alpha radiations, they're stopped from going through a piece of paper, while the beta radiation, they are faster, they have more energy, so they can penetrate further than the alpha particles. The beta particles, they are capable of penetrating the skin and causing radiation damage, such as skin burns. So basically, the dangers of the beta radiation, they are clearly more dangerous than the alpha radiation. As with alpha emitters, beta emitters are more hazardous when they are inhaled or swallowed or absorbed into the bloodstreams through wounds. The beta emitters are also dangerous. Beta radiation is, in conclusion, more dangerous than the alpha radiation. Third type of radiation, we have the gamma radiation. The gamma radiation, they are protons. They are light. They are very light, except with a very high energy, typically from the several kilo electron volts to several mega electron volts. X-rays and gamma radiation rays are very similar. The only difference is the way they are produced. Depending on the energy, they can be stopped through by a thin piece of aluminum foil, yet they can penetrate through several inches of lead. The extremely high energy of gamma rays allows them to penetrate just about anything. They can even pass through bones and teeth. Thus, the gamma rays are very dangerous. They can destroy living cells, produce gene mutations, and even cause cancers. So, in conclusion, we know that the gamma radiation are the most dangerous and the alpha radiation are the least dangerous. So, I'm going to explain briefly what I mean by the penetrating and the stopping by the paper and the lead. We have here this diagram right here. This is the alpha, this is the beta, this is the gamma. We mentioned that the alpha, they are fast-moving helium atoms. The helium atoms, they cannot really penetrate. They have a high energy, yes, but they cannot penetrate, they cannot move into objects like the gamma and the beta. So they are less dangerous than the two types. They can be stopped by simply a piece of paper. So the beta radiation, they can penetrate more. They can penetrate several feet of air, and plastic. They can be stopped by a piece of aluminum. Just like the gamma rays. Now like here you see the arrow is moving through the piece of paper. It cannot be stopped by a piece of paper. The beta cannot be stopped by a piece of paper, but it can be stopped by a piece of aluminum foil. Here, the gamma radiation, it can penetrate through several inches of lead, which this is why they are more dangerous. So here we have the electromagnetic spectrum. We mentioned earlier that heat transfer through radiation is moved through electromagnetic waves. So this is the electromagnetic spectrum. We have the gamma rays, we have the X-rays, we have the ultraviolet light, we have the infrared rays, radio waves, microwaves, television waves, and the radio waves. So here are the gamma rays. They're the most dangerous. Then we have the X-rays. Then we have the ultraviolet. And this is basically the visible lights, and basically the colors. We have here I listed some examples of radiation. We have the ultraviolet light from the sun. Obviously, here it comes right here from the sun. The visible light from a candle. We have this is the visible light. They come in between the ultraviolet and the infrared. And we have the X-rays from an X-ray machine, obviously. The sound waves from a stereo. We have the electromagnetic waves from a cell phone. Microwaves from a microwave oven, and radio waves and laser beam. Those are all examples of radiation. So thank you so much for listening. I hope you understood.